Hello and welcome to section 6.4 through 6.5. In this video we will introduce the method of sections as well as three-dimensional trusses. So the method of sections builds on what we looked at last time with method of joints. It's the idea that we can, if we want to solve for an internal force, so you can see we have internal forces in the diagram here, we need to first make them external so that we can solve for them. We do that by virtually cutting through the members and exposing those forces. The difference with method of sections from method of joints is that we get a series of rigid body equilibrium problems. In method of joints, we had particle equilibrium problems. So that means we get an additional equation. So let's look at just another connects example here. So we have this simple truss here. And if we modeled it as a rigid body, we would have some external forces here, here, and here. So this one would be pinned, this one would be a roller. And then if I wanted to solve for these internal forces, so say I wanted to solve for this and this, so what you would do is you would pretend to cut through these two forces, and you would reveal the forces on the inside. And so now what we have on this side over here, I have, so this looks like a method of joints problem, but it's actually a rigid body. And over here is a rigid body as well. So we have two different rigid bodies. So I can now have my two forces. Remember that these forces, so for instance in this yellow member here, these have to be equal in magnitude and opposite in direction so that when I put it back together, they cancel out. If they don't cancel out, then this body is not rigid. It'll be collapsing, kind of like if you pushed on like a piece of foam or a piece of jello. So if I wanted to solve for, say, this force up here and this force down here, I have two different rigid bodies I can use. I can use the one over here or the one over here. So I'll just kind of draw a box around this one over here to make it easier to see. So this would be kind of like a rigid body over here. Inside of this rigid body, so this is basically a free body diagram. I have 1, 2, 3, 4 forces. 2 of them were external and 2 of them are internal. But I still have 4 things to find over here. If I go over here and look at this one, I have 1, 2, 3. So there's only 3 for this side. So if you were trying to find just these two forces, you'd be better off solving for the right side. And ignoring, you wouldn't even use this side. You would pretend it doesn't exist. You would just solve this rigid body, sum of forces in the x, equal to 0. Sum of forces in the y, equal to 0. And because it's a rigid body, you'll have dimensions. You can also do sum of moments about some point equal to 0. And you can do multiple moments. So if you only wanted to find, say, the purple ones without finding the external force, if you did a moment about this point, you would find just this one. Then you could do sum of forces in the x and find that one from that one. And then you'd be done without ever having to find this red one. So you can be very strategic about this and save yourself a lot of equation work if you can kind of think about what do you actually want to find and what do you not want to find. All right, so let's talk about space trusses. So a space truss, and sorry I didn't make one. These are three-dimensional trusses. So this is the simplest one here on the screen. We have 1, 2, 3, 4, 5, 6. There's 6 different members here, which means there's 6 internal forces. To find 6 internal forces, you would need 6 equations. If you wanted to find all of them, then you'd probably want to use method of joints. Method of joints is really good at finding all of the internal forces. If you only wanted to find a subset, then you would do method of sections. Method of sections is really good for finding a specific set of internal forces instead of all. So if you want all, use method of joints. If you want some, use method of sections. So in 3 dimensions, when you do method of joints, so say you did it down here for this one, I'll leave my cursor here, you would have 3 members, but you'd also have 3 equations. You would have forces in the X, forces in the Y, and then forces in the Z because you're now 3 dimensions. You would actually probably start this problem up here at this joint because you'd only have 3 members plus, assuming they gave you P. If you knew force P, then you could solve for all 3 of those and then cascade through like you did with the 2D problems. All right, so in the next video, we'll actually apply method of sections to a 2-dimensional truss. If you have any questions, feel free to contact me.